Hey guys, so last time we talked about finding slope of a function at a specific point. So remember we said slope was rate of change. So when we found rate of change at a specific point, another way to describe that is the instantaneous rate of change. Instantaneous rate of change. That means if we were talking about your rate of change being your velocity, your speed, right? If you're driving along in the car, right, you're not always going at the same speed. Sometimes you're going at 50, sometimes 60, sometimes 40, and so on. However, if at any given time you look at your speedometer, whatever that reads at that instant, that is your instantaneous rate of change. Now, let's talk about a different rate of change. All right. Let's suppose you went on a road trip. Okay. And let's suppose that you drove 300 miles and it took you 6 hours to do it. Right? What was your average speed, your average velocity? Well, it was 50 miles an hour. So on average, you are going at 50 miles an hour. That is your average rate of change. Now, could there have been a time where you looked at your speedometer and you were going exactly 50 miles an hour? Yes. So there can be moments where your average rate of change could equal your instantaneous rate of change. And we can get to that later on. But today we're going to focus on average rate of change, right? So this is the total change in y over the change in x. All right. So not like when we're going over, an incremental amount. No, it's the total change in y over x. Okay. All right. So the average rate of a function over time, specifically over the time interval a to b, is this formula right here. It's f of b minus f of a over b minus a. Okay, so this is, if I have a curve, okay, and suppose this is a and this is b. So the average rate of change is f of b minus f of a over b minus a. So basically what I'm doing then is finding the slope of that line. So remember, this is the slope of the secant line. So last time we talked about the fact that instantaneous velocity was the slope of the tangent line and instantaneous rate of change was the slope of the tangent line, and average rate of change is the slope of the secant line. All right, so an example of rate of change is velocity. I already started talking about it. Now, one thing we need to be clear on, however, is this. Now that we're going to be talking about, physical quantities, right? It is very, very important. Physical or not, actually, I take that back. It is very, very important when we're talking about average rate of change that we keep the order, right? So it's f of b minus f of a. It's y2 minus y1. That makes a difference, right? Because let's say we're talking about a change in temperature. And suppose the temperature in a certain room or in a certain city went from 90 to an 80. Right? It's important that we do this subtraction in the right order. The change in temperature, right? In science, we use delta, right? So the change in temperature, delta T, is final minus initial negative 10 degrees. And that negative is important because it says that, yes, the temperature changed by 10 degrees, but it's a negative change, meaning it went down. So that negative is very important. So it's always f of b minus f of a, final minus initial. All right, so the first example we're going to talk about is velocity, and we're going to focus on velocity for the rest of this unit, actually. Velocity is the rate of change of, position of an object, right? So what's your speed? Your speed is, this many miles an hour. What does that mean, really? It's how quickly you're getting from one point to another point, right? So it's how quickly where you are, your position is changing. So that's all velocity is. Average velocity is the total change in distance divided by the total time. Now, what do we call this total change in distance? There is a special word for that. That's called displacement. Okay, displacement. So the average velocity of an object with position s of t is the displacement over time. Now, displacement is the change in position, and it also has a direction associated with it. So that means if you have a displacement of negative 5 meters, that means you went backwards or in the negative direction 5 meters. If your displacement is positive 13 inches, that means something moved in the positive direction, forward 13 inches. So average velocity is total displacement over total time. This is the final position minus the initial position over T2 minus T1. So let's take an example here. And before that, let's just specify one more time that if I have S of T1, that is the position at T1. Okay, let's take a look at this example. A water balloon is propelled straight up using a launcher. The height of the balloon in feet, t seconds after it is launched, can be defined by d of t. What is the balloon's average velocity between t equals 1 and t equals 2 seconds? Well, the average velocity is equal to the final position, and if position is d of t, right, what's its final position? It's d at t equals 2, d of 2. And then what's the initial position? It's d at t equals 1. So let's just evaluate that for a minute. D of 2, you put 2 into the function. So 5 plus 65 times 5 minus 16 times 2 squared. I'm sorry, 65 times 2. So that equals to 71. Okay, so V average, if we continue, it's D2 minus D1 all over 2 minus 1. This is 72 minus D1 is 54 over 1. So V average is positive 17 feet per second. And you obviously don't have to write that plus sign, but there was a reason why I wrote it. The fact that it's positive means this has a speed of 17 feet per second, and it's moving in the positive direction. Okay, and where is the positive direction in this problem? This is a water balloon that's propelled straight up. So the positive direction is upwards, towards the positive y-axis. So the balloon, well, we'll talk about that later, right? So the average velocity is positive 17 feet per second in the positive direction. Okay, Now, the instantaneous velocity, remember, is the velocity at a specific point in time. So the rate of change of the slope of the function at a specific point. So remember, if you were doing your road trip and you had an average speed of 50 or 60 miles an hour or 50 miles an hour, if during that time you looked at your speedometer and it read 62, that is your instantaneous velocity. Okay, your speed at that moment in time. And that has the same formula as what we talked about yesterday. So the limit as h approaches 0, s of t plus h minus s of t over h. So let's go ahead and do this next one. A window washer accidentally drops his lunch off his scaffold. Poor guy, 1,400 feet above the ground. So this is where he is. If this is the ground, he's 1,400 feet up. You know, he's standing right there. And then the lunch bag, you know, it just falls 1,400 feet. The position of the lunch in relation to the ground is given as this function, where t is given in seconds, and the position of the lunch is given in feet. Find the instantaneous velocity of the lunch at 7 seconds. Okay, instantaneous means we have to do it the way we did it last time. So, here we go. V of t is equal to the limit as h approaches 0 of d of t plus h minus d of t all over h. So v of t is equal to the limit as h approaches 0 of 1,400 minus 16 t plus h squared. Now that's d of t plus h minus, what's d of t? 1,400 minus 16t squared all over h. Now we need to simplify all of this. So this is going to be the limit as h approaches 0, 1,400. Okay, now here's what I'm going to do. Minus 16 times t squared plus 2th plus h squared minus 1,400 plus 16t squared, okay, over h. Can we get rid of these 1,400s? Of course we can. Let's simplify the rest. Negative 16t squared minus 32th minus 16h squared positive 16t squared all over h. Okay, stuff should cancel. 16t squared, negative 16t squared. Now, can we combine another step here? So I have the negative 32th, negative 16h squared over h. I'm going to cancel out 1h from everywhere. So finally I have v of t is equal to the limit as h approaches 0 of negative 32t minus 16h. Okay, now I substitute, I put in h equals 0, so v of t is negative 32t. Okay, but what's v of 7 then? V of 7 is negative 32 times 7, which means v of 7 is equal to negative 224 feet per second. All right, and so what does that mean? The lunch has a velocity of negative 224 feet per second, which means it's falling down with a speed of positive 224 feet per second. Okay, so that's important. Once you say falling down, you've specified the direction, so you don't need the negative anymore. Okay, so if you said it's traveling, then you would say with a velocity of negative 224. But once you said it's falling or falling down, then it's with a speed of positive 224. All right? And when is this happening? At t equals 7 seconds. Okay. That part here is just as important as your answer as we're moving to calculus. Okay? Let's take a look at this next one. The distance in feet of a water rocket from the ground after t seconds is given by this. Find the expression for the instantaneous velocity at a time t. Okay, let's do it. Again, so instantaneous velocity, meaning we want v of t to equal the limit as h approaches 0 of s of t plus h minus s of t all over h. Okay, s of t plus h. Okay, what is that? That's 90 t plus h minus 16 t plus h squared minus, what's s of t? 90t minus 16t squared. Okay, so now we're going to have to simplify all this. So let's see, limit h approaches 0. Oh boy, all right, so let's do the red stuff. It's 90t plus 90h minus 16t squared minus 32th. I'm just doing the whole thing, minus 16h squared. And a lot of that is going to be very, very, it's just going to be repeating, right? Negative 16t squared minus 32th, because it all has to do with like the physics formula of something in either shooting up or falling down. So that's normal that you get things that repeat. Okay, the 16t squared, that has to do with acceleration due to gravity. Okay, all right, so 90 minus 90t plus 16t squared over h. And now my favorite part. Okay, let's see, 90t minus 90t, 16t squared minus 16t squared, all should cancel. Okay, so now I'll get another color and I will cancel out an h from everywhere. This has to happen every single time. That h at the bottom must go away. You have to make sure that at the end of the problem the h's go away. Remember, it's a constant you put in, so you can't have it stick to the end. So this is 90 minus 32t minus 16h, and then when I plug in h approaches 0, I get that v of t is equal to 90 minus 32t. And now, because this was saying find the instantaneous velocity of the rocket at any time t, there is no value for t to plug in, so that is the answer right there. And that does it for today. You can go ahead and do the homework. Thank you.